All right. Um, hey guys, welcome to my channel. I'm Iggy. I'm a web developer in sunny Brisbane, Australia, and it's 7:46 a.m. Let's crack just a little bit of code. Let's continue this random dungeon map generator. Last time we actually just achieved to create all the different rooms, and now we are trying to actually just build these blocks, basically, that it's nothing. But we need to actually just align them. So that's actually what we're going to do. And once we got this one up and running, what we can do is actually just creating the randomness of the map. And I think that actually it would be good to do this one. And you can see that the whole thing, let me just inspect this one so you can actually double check it as well. We can see that the whole thing is basically based on an SVG. So the whole thing is going to look good even if you actually scroll up and down, if you actually zoom in or zoom out. So let's just try to do this so you can see that it still is actually looking very sharp. Sorry about that. I think this is actually looking very sharp. You can see that the positioning basically of these elements are not right. So I think this one should actually go up. The problem though is that on the code that we have, basically what it's doing is actually rendering everything as we tell. So basically it's just like go first element, render this, go second element, render this, go third element, blah blah blah. The problem with this approach is that, for instance, this one here, once you tell him that it needs to actually just be on the next element that needs to be rendered, it's gonna just render on top of anything. It's going to be the next step. It's kind of layering, basically. It's like onions, basically. So you have a layer basically that sits on top. So if I, for instance, this is actually a transformation function that I got. So I'm saying basically just go down 40 pixels down. But if I try to actually just modify this one, we can see that you see that effect is actually sitting just in front of the other one. And that's something that we don't want. And that's why this one here, it should be actually be 40 pixels, but it's not. So yeah, we can see that if I put actually 40 pixels, it's actually kind of weird. And then similarly, whoops, what I'm doing now? Okay, if I do the same thing here, we can actually see that it's actually kind of the same approach. This one though is actually fine because this one sits before the next one, so the next layer is gonna sit on top of the other one, so that's kind of fine. But this one is not. This one, if we go here and we actually just say let's just go up, there you go. So we see that it is correct, but it doesn't mean that it's right. So technically this should be not 35 but 40, and then this one should actually be, or the elements that they are not right, it should be rendered before, and that's a problem. So now here we can actually double check everything fits. We have our element translated to the specific position, and basically it's just collapsing with this border here, which is actually something that we want. So the problem is we need to first render those elements that they are on the back, if you want, a layer that is actually sitting on the back, and then we actually put everything else that sits on top. Another thing that we can do, and I know that this could actually solve our problem, is instead of actually rendering every single object here like a block, we just say, you know what, I don't care about this. What we are going to do is actually just style the whole SVG with some background basically, and we are going to put it at like, let me see, not fill. Let me see what do we have here for the SVG. you can see here that we actually did is actually just say, like, you know what, all the SVG, it's 100% of the size, 100% of everything. So what we're going to do is actually just say, I don't care. I just want to actually have some background, and then just we can actually leave it as like empty. So we don't render these ones. They actually should be already there. And then what we do is basically just rendering the path of whatever we want. And that's pretty much it, actually. So we can see that, for instance, if this is actually your init place, you can actually go to the right, down, right, down, down, right, and then you go to whatever destination that you want. So yeah, that's pretty much everything. The only thing though is this actually is based on like the size, which is 100% of the size. However, you can see that it's not right because we got this extra space that we are not doing anything with it. So what we need to do here, if we know what actually the size of these rooms they are, we can actually just say, okay, well, let's just put it like size of the map times the pixels. So how many columns times the size of the pixels, and then how many rows size of the pixels, and then that would be actually the width and height of this one. So we can actually do that very easily. So let's just have a crack of this. So let's first go to this one here. So we know actually that we have the size, so that's actually something that we can do. So we know that is actually size. What we're gonna do is actually just put it this way, okay? So even because now we are actually talking in pixels, well, you can actually just put it size because it's actually taking in consideration that they are pixels by default. Okay. Oops. Okay. So this should actually be rows by the number of rows, and then they should actually be by the number of columns. So now we have this one here. It has been already been defined, and then we can see that the map is actually more or less correct. And what I'm saying actually more or less correct is because we have like each element is 40 pixels. So we have 1, 2, 3, and this one is actually width of 35. So we can actually put it this way, and then the height should actually be as well 40 pixels. To be honest, I don't mind to be at the moment. I don't mind. This one is 35, and this one should be, I think, probably this should be this, and I'm right, yeah. All right, yeah. So what we can do is actually just, oops, sorry about that. Here we go. Yeah, so we have this one. We need to consider this minus kind of, okay, let me think. We need to consider 5, so the size is going to be size of, okay, give me a second. Okay, so the size of the width is going to be the size of the columns minus 5 pixels, because 5 pixels is basically this kind of thingy here, and times basically minus 5 times, I don't know why I'm doing this one, like 5 times the columns. And similarly, we need to do the same thing, oops, minus 5 times, and then the size of the rows. Okay, let's see. All right, so let me just double check this one here to put it actually Okay, so this is correct, this is correct, this is not right. This should actually be 70 instead of 80, the translation. 70, that's correctamundo. Yes, because technically we have 5 pixels that we didn't actually take it into consideration. So now they look properly good. So that's good. Then we have this one here, and then this one is as well kind of similar issue. Let's just put it into, so we have like, this is actually probably this, it is. Oh my god, I'm so good. Problem that we have similarly, this should be 40 pixels, this should be 40 pixels as well. Oh man, I feel like I'm a Google advocate or something like that because I'm saying pixels so many times. You're a Google Pixel. Okay, so we got this one here, and then probably this is 110, maybe. No. Yeah, so that might be 100 pixels, but that could not be. Okay, let's do one thing. So technically, we have another issue, actually. Right, -1. -1, my friends. Choo. Here we go. Now it looks nice. Okay, what I'm gonna do is actually remove this whole thing. We are gonna leave it as is, and we're gonna just place some background, like just background color, the same one. So it could be actually like, what do we want? What do we want? Yellow, green. There you go. And then let's just put it here. So we got H1. We have. Let's do SVG here. Now we are gonna put like, okay, for the SVG that we have, we're gonna do a background color of yellow green. So that should be okay. So now we got it. The good thing though is because this is actually scoped to the specific app, then the SVG on the app is going to be just a style. The other ones, they are not going to be a style with that. Like these particular styles, they are scoped to this particular component. So that's actually a good thing because it means that the inner components, they are not going to inherit, or there is no leakage basically on the styling point of view. So now what we can do is actually say, if there is anything else, then we remove this and then we save it, and then everything looks nice. We can even leave it as is, or we can actually just put something here. So instead of actually declaring the styling here, if we want to do that, like kind of, how to put it, if we want, for instance, like be programmatically, or we can actually just pass a configuration file or something like this, what we can do is actually just put it here. So we got a style that is going to be like a string, and then the string could actually be as well a template string, and then I'm going to put it like this, so then we know exactly that it's a template string. At the moment, I think I haven't these tensions for Svelte. Nope. So I think this is actually the one that we want, if I do remember well. This is actually good because then it means that your code is gonna just be highlighted, all these different things in VS Code. Sometimes you need to find what is the best extension for VS Code. The problem though with VS Code, and this is actually a good thing and a bad thing, is there is a lot of things, and because there is a lot of things, you can see that technically most of the times you don't know what you have to install. So yeah, that sucks. But anyway, let's just, this is actually installed. Let's just keep it here, and then we can actually say that you want your background color. So let's do that. So background color is about yellow, green. Now we save it and done. Boom. Let's just think about, oh, I want to actually just pass something here different. So now what we need to do, because we are on a template string, we can actually say background color, whoops, background color. And then basically in this, we can actually say we got here, let's export let, and then export let background color, and it's gund, okay, background color. And then similarly, we actually need the styles, so this is actually something old. Okay, let me double check this one, because I'm not sure that we are just, yeah, that's fine. Okay, yeah. So this is actually something that we used before, and we are no longer using it. All right, so we have export, let, and size, and then this could actually go out. Similarly with all different things, but yeah, let's just do a little bit of work there. Let's go here. We got props. So it's actually the name. This is actually the old stuff. We can actually say size is going to be 40, and we can actually say background color. It's going to be what we wanted basically before. So it's actually just 333. And then we can actually just remove this, save it, done. Boom, booyah. So we can actually see that we have already this map. It's clean and tidy. I think this one has been like, yeah, it's on 170, but we can actually see that we actually 100% is actually fine. And then we can actually just go up, go down, and it still is looking good. So yeah, really happy about this, to be honest. The only thing though is my SVG is of size 145, 100 something. So basically it's actually just at the moment it's, yeah, taking that space. Let's just think about what happens if we actually just put 100 size for everyone. Right. So it's not bad, you know, we can actually see a lot of things. But you see that, for instance, this one here, the main is actually saying like my max width is going to be 240. So yeah, we need to actually just restrain this one, but at least we know that no matter what size that we pass, they're going to just behave correctly. The only problem that I'm having at the moment with this is like every single time we actually use this to be 5 pixels. So I don't like it. So this one, for instance, is 90, but I guess we need to actually just pass it more. So it's gonna actually be 80. 80? Or we can actually just buy 85. I think 85 is fine. Yeah, I kinda like this one better. Oh no. I know what happened. So basically we are positioning this one, but we're not taking into consideration anything. So basically This is something that we got from this size, but we are not doing any kind of translation or transformation of this item and then positioning this one right away. So technically this is correct. And then what we need to do is actually similarly to what we did before. We do a transformation, a CSS transform with translate, and we can actually just do, we do 3D because we need, we need to get this one down. So this is actually 5, and then we need to actually provide as well 5, then 0. This is actually in pixels. So let's see. It didn't do anything at all. Why? Five pixels. Let's just do 10. Oh, there we go. 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 Oops, not 9, but 10. Okay, so we can see that this is actually way better. So we got, instead of 5, now we actually just got 10. Looking good. Then we need to actually just apply kind of the same reasoning to these doors. So yeah, we need to think about this one, and then let's double check what happens if I do the oh no, because I'm gonna save, and because of the hot load reloading, it's gonna just, yeah, there we go. This is nice. This is nice. It's not bad. We can actually use this one here. We can actually just start introducing basically that kind of randomness to the map, and then once we got that one, we can actually just pass that data into this. So for instance, here what we got is actually this dungeon map, these rows, columns, all these different things. We are passing basically the size and the background. Probably we can generate this one randomly. And then because we are just generating this thing randomly, it means that no matter what we do, it's going to be okay. So let's just think about some random functions that we can actually just run. Here we have the row, and now we have here. So basically we need to randomize or create a random function, create random dungeon. Super original, super duper original name of a function. By the way, this is an arrow function. Yeah, I use it, I like it. People in React actually use this a lot. Yeah, we can actually use this one. Okay, give me a sec, just coffee time. Wow. Okay. So, create random dungeon. I got this one. So we need to use the random function. If we think about it, let's see. Okay, let me just open this. Do random function. Just see. Boom. And technically probably we got math random, which is something good. And basically we actually just provide a number between 0 and 1, which is a floating number, which is fine. So that we can actually do that. So math.random01, and then basically we want to do this, and then because it is 0, which is inclusive, it means that it could be 0 or something else. So technically what we can do is actually just say, okay, what is my max thingy? So for instance, something that we see here is that you have this function. So basically you have your max, which is mathflow max, which is, interestingly, mathflow max of 3 is basically 3, because there is no decimal there. So I'm not 100% sure why they use this one. But for instance, you can do like your size of rows. So you got this one, and then you do math dot floor, and then basically is this one. And then you can do as well the same thing, so you know exactly what are your rows. Wait. Okay, so you have a max number of rows that you want to use, but in order to randomize this, we wanna do is, okay, so you have a const which is going to be n rows in your map, and then those are actually just basically saying like we have from all the 4 things that we have, like let's just go back to this. So from all the 4 slots that we have here, then we can say I want to have X amount of rows. Does it make sense? No, okay. Yeah, no. So we need to actually just get the positioning basically for these particular elements. So we need to actually just have an n row, n column. So then you can actually just say on this position of the map, let's just say this one here, you need to actually say, well, it's going to be on the 0, 1, 2, 3, and then basically this is 4, so it's fine because 1 is not going to be included, so it's going to be 0, 1, 2, 3. So it could be 3, and then basically afterwards we have 1, 0, 1, 2, so it's going to be this one here. So it's a similar thing. We need to have floor math dot random times and the columns. So now we got these positionings. So we can actually just call it basically pos y and pos x. The problem though is actually what happens if you have already a position with that. So either if there is already something in the dungeon, in the array. So let's just create this dungeon on map. That's a good name, dungeon on map. Okay, so we got this one, which is an array, similar to what we got here. And then what we need to do is check if, for instance, the pos x yes. So you need to check if pos y times the number of columns times the number of rows plus x has already something on it or not. What that means is, for instance, let's just say we're still actually this element here. So what we do is basically saying like, okay, my pos y is actually like 2 multiplied by the number of rows sorry. So we get that one, so we know exactly that we have 2 times row it's 4. Okay, so let's just put it here, the math, and then we can actually see if it's correct or not. Time 4 plus, and the position is of pos y is basically how much do you have between this. So it's going to be 0, 1, 2, 3 plus 3. So we got like 2 times 8 plus 3, which is like 11. So we can actually just double check that one if it matches or not. So we got 1. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. But why 11? It should be here. Well, technically it's correct because we start with 0. So basically it's 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So that's fine. So we need to double check. With this particular condition, we check if there is something there. So if dungeon map of this position is already has something on it, what I'm saying is different of -1, then you need to recalculate. Calculate new. Okay, let's just put it here first, a comment. Recalculate positions. So this is actually something that we can actually just refactor, because we are going to do this a lot. So we can actually just create like a function that is going to be generate positions. Generate positions or coordinates. I think it's better to actually just call it coordinates. So we get this one. Basically what we do is actually just return, and then we return, to be better, we can return basically like post y. Whoops. Oh, you know what? Let's do it this way. Post y, and then so we return an object, which is actually what we want of the positions that we want. Okay. So we get this one, and then we got this one. Boom. There we go. So now we can actually just come here and say, okay, well, generate the coordinates. And I'm gonna just store these ones on, let's just do a destructuring basically. And I'm gonna call it X and Y. Oops. Okay, now we can actually see like, okay, so let's just do this. So in this one, then we need to recalculate positions. So while, I guess you need to actually do this as long as the positions don't do anything, like they have something on it. Okay, so we do this. Yeah, I think it's better if I do this. Pause equals, let's just put coordinates equals generate coordinates, and then basically we can do coordinates coordinates dot x, and then basically we do say the same thing. So we are doing coordinates, because we are actually just restoring this thing over and over and over. Okay. What else? Yeah, so we need to create this dungeon map. So at the beginning, at the very beginning, what we need to do is actually just create that massive array. So what we're going to do is actually just start this by iterating through it. So let's just say let e equal 0, e less than rows times columns, and then basically this is equals to this. And then what we're going to do is actually just say, you know what, go into the dungeon map, and then for everything that is inside this, you're going to set to -1. So then we know that in this particular case, let's just, yeah, yep, okay. So we got, while this is actually this, then you would actually, oh my god, yeah, here we go. So we got let r equal 0, then this is this, blah blah blah, and then dungeon map -1. So this is actually what it's doing, is actually just generating a map with nothing. Literally. That basically is just calculating coordinates, and while the coordinates, so if for instance you have something on the map that is like different to something like -1, you will actually still keep working out. Okay, so then what we need to do is we need to consider different options. First is we need to consider walls, the walls. We need to consider directions, and that's pretty much it. So basically we have 4 ways. Okay, so we have 4 ways, directions, 4 ways. These 4 ways, sorry, just put me here. So this is actually 4 ways. So these 4 ways, what is going to happen is basically saying, okay, I can go up, I can go down, I can go left, or I can go right. So what it means basically is that your array, so on the dungeon map position, okay, definitely today that's not my day. On the dungeon map position you have this one here, and then basically it's like, okay, I need to consider this x. Okay, so this is going to be actually a little bit tricky, but it's going to be on the right, it's going to be this one. So let's just put it here. So we got, let me just do one thing, it's going to be easier. So I'm going to put a multi-comment line there. Okay, cool. Let's just do a little bit of padding, boom, 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 there we go. Okay, so this is right. This is left, so dungeon, map, whoops, of x minus 1. I'm gonna just put it actually position index if you want. I think it's gonna be easier. So then what we need to do is consider basically up and down. Up and down, they are tricky because we need to consider those options. So it's going to be dungeon map. Now basically that position, we need to remove 1 row or add 1 row. So for that we need to say pos index minus number of columns minus 1. Sorry, number of columns. Yeah. So that actually just remove one of the rows, and then that was gonna be dungeon map, and then basically pos index plus number of columns. Okay. So these are basically the 4 ways. However, we need to consider the walls basically of the array. We cannot actually just go outbound of the walls. So technically you cannot actually go up if you are on this particular cell. You cannot actually just go left if you are in this cell. So you need to consider, if you are on this one, you cannot never go on the left. So technically you need to consider some very different options. So what we need to do is actually just double check this one out. So for instance, let's just say that if you are on I0 basically, or the first row of the column, if how did I put this one? So if for instance if x equals 0 basically, then it means that we are on this position. So there are a couple of options here. So okay, let's do this. So if x is equal to 0 and y equals triple equals, you have equalized. Okay, this one, and then technically afterwards we can actually do similar things. So we have this one, we have as well a similar one, which but technically is actually the bottom. So this one, and then columns -1. Remember, we are actually just not going into 1, 2, 3, 4, but we are going to 0, 1, 2, and 3. So that's why column if is 4, then we need to actually just provide the maximum is going to be columns on the number of columns -1, because we are starting actually on 0. Yeah. Anyway, so good, that's one. So this is actually to say if we are here, or if we are here, then we will actually have something similar here and here. So technically, if let's just put everything, all the conditions. I think it's going to be easier to understand. Never left. Okay, let's just put it here. If y is equal to 0, never up. If y is equals to never down. And we can actually do the similar thing here, where it's like if x equals columns -1, never right. And this one is not rows, but column, but it's rows. Oops, reeves. So now we know, like, if we are on this position, I can never go to the left. If we are here, I can never go to the right. If I'm here, I can never go up, and if I'm here, I can never go down. So these are kind of the conditions that we want, and then we need to double check them once you are on these particular spots, which is actually the corners, because a corner you can never be either up, left, or something like that. So you need to consider those options as well. And then basically afterwards we need to consider, for instance, if we actually on this one here, we need to consider if this one is open to the right, is open to the left, which means that you need to double check the previous and see if the access the access property has a east on it or not, in order to actually just communicate both cells together. All right, it's a lot, kind of a lot. Okay, let's see. So right, and then this one. So and then I forgot, we need to actually just as well create a randomness for which one are communicating. Again, I think that would be useful. So we can actually just create or generate like the I think we can actually just do is actually just generate everything similarly to what we got before, in the sense that I'm going to just create a random thing that will actually just append to an array whatever directions that we want to be connected, and then basically after that it's going to be automatically done. So yeah, so let's do that. So it's not going to be connecting through like the access property, as I said before. I forgot that the dungeon map is different from the actual implementation of the object, or the room object. So what we need to do is actually make sure that if you got an A, you need to match it with a W. So let's double check that one out as well. So let's just create another function here to just generate basically the arrays or the access points. So let's do that. Generate access or doors. Let's just call it doors. Generate doors. Cool. So we got this one, and then we're basically what we said. It's a similar thing. We need to actually have 4 items So from those 4 items, what we need to do is actually just put it into an array. Depending actually which one that you get, it's going to be either north, south, east, or west. So what we're going to do is basically pretty much something similar to this. So it's just going to give you the how many. So this one is how many. We got an array const doors. Sorry, we got the doors, which is an empty array, and this is not a let. How many doors do we want? So basically this is gonna be like columns, directions, ways. Do we want to call ways or directions? Ways. So we can go up and do the similar thing. So technically these ones, they should actually become part of like a configuration file or something, and we will extract those things afterwards, but for now it's better. So technically it could be actually just 4 ways at the moment, but I've seen in other places that you can actually have like 8 ways. So it's going to be like south, east, southwest, blah blah, etc, etc. Oh, my bad, sorry. Oh wow, sorry about that. Okay, how many? Then we got the number of ways. Then for each door, then what we're gonna do is like a 4 while. Let's just put it like a remaining equals how many. What I'm saying here is basically what I want to do is actually say remaining, while remaining is superior to 0, meaning that while you still actually have to generate new doors, you keep doing this bit. So what we do is actually just saying like, okay, well, I'm gonna do a switch case for something, so the door number. So which door do we want? So it's similar thing. So first we know exactly how many doors do we want, but then afterwards we need to know exactly which of the doors that you want to do it. So what you do is basically saying like, I'm gonna just do this bit here, and then basically which door, and then we have a switch case here. So it's gonna be case, it's gonna be 0, case 1, whoops, this is actually a break. Let me just copy this, default, it's gonna be break, I'm gonna breaks, okay, break, cool. Look at this one. So if this one 0, we're just gonna start with n, with north. So what we're gonna do is actually just say, well, we're gonna push to this array, we're gonna push north, and then similarly we're gonna do the same thing. So we can actually just copy paste this one, boom, another one, and another one, and another one. So we're gonna just do this, we're gonna loop through south and then west, done. So this is actually just saying like, okay, we're gonna generate doors here, and what happens at the end is once we got this, the problem here is actually just an infinite loop. We are not actually doing anything. But here, what we need to say is remaining minus. And what this does is actually say like, already, we have already something here. And similarly, we need to double check if the doors of I of dot includes, oh god, okay, let's see. Okay. Give me a sec. So what we can do is actually, give me a sec. Okay, so we're gonna say door and then an empty string. And then basically, instead of actually just pushing straight away, we're gonna say is actually door is equal to n. We are not yet actually doing anything, so we are not actually taking out remaining, because we need to double check if that actually is okay or not. So what we're doing is just assigning the door. So this door equal something, door equal dot da, da, da. Cool. Now at this point we know that the door is there, so we need to double check if door or doors dot includes already on this array the door, and if so, if it hasn't, then what we do is actually just push that. So dot push door, saying like, hey, on these doors, do you have this door? Yes, no. If you don't have it, just put it there. Otherwise, just keep doing it. So then we actually, what we do is actually saying like, okay, well, push it. Then I'm gonna say like, okay, done on this particular way. So now we can actually just take one out, and then that's it. So this will take you all the items, and then basically at the end, what we need to do is actually just return the doors. Okay, so if we want to actually just make sure that this is actually okay, what we can do is actually just go to the console, paste this one, create as well like a const ways equals 4. Do we need anything else here? No. Okay, so now we can actually just see if it works or not. We have an array with nothing. We have an array with s, nothing, and then b. There we go. So there we go. So we can see now that this actually works. It gives back basically that kind of door elements that we needed. So that's good. And then basically we can actually just generate iteratively this kind of things. So basically here we need to recalculate these ones, and then we need to generate those, and then we generate these doors, and then basically the dungeon map, it's equal the dungeon map on these coordinates. So let's just put it this way, so it's going to be easier to do this. So let's just declare a constant, because it's going to be iterating this over time, so it's going to be a constant here unless it changes afterwards. So let's just put it this way. So we can actually say the index, and then this one here, and then similarly index. Yeah. So what happens here is now every single time we generate these coordinates, then we store this into an index, and we say if there is nothing on that index, then if there is something on that index, we need to recalculate these ones, and then we generate the doors inside, and then that's it. But this only generates basically the coordinates thingies. So we need to, this only created once, so it only creates one. So this will be an iterative process that we need to actually make sure that it loops through and it creates or regenerates these ones. But we need to actually have a connection between the start and then the finish point. So we need to probably tag those ones. So let's just put it here, what we need. So we need a starting point, we need an endpoint, we need a loop, loop for filling the dungeon map. This is actually what we need. Okay. We'll calculate the positions. We need to actually make sure that we are careful with the directions. So block or avoid to actually avoid exit the bounds of the array of the map of the dungeon map. And that's pretty much it, I guess. Once we got this one, we probably want to double check a couple of other things, you know. But I think it's gonna be for the next one. All right, so we got an under map. We got already something that is rendered properly. We'll start generating these functions to actually just go and say like, oh, I want to actually just generate the coordinates. I want to generate the doors, and then we need to start actually interconnecting those things. So probably what we're going to do is basically just taking the directions and then saying like, okay, you need to interconnect both things. So if you have an E on the left, you need to actually have a W on your position. So probably I will actually just do that and then explain that in the next video, and then we will take it from there. I think it's gonna be good. So yeah, thank you so much, guys. Subscribe if you like it, leave a comment, yeah, and see you next time. Bye.